Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on application of a derivative. First we will discuss on increasing function and decreasing function. What is increasing function? The function fx is said to be strictly increasing if f dash x greater than 0 and it is said to be strictly decreasing if f dash x less than 0. First question, so that the function fx is equal to sq minus 3s square plus 6x minus 100 is increasing on R, that is real set. Answer, fx is equal to sq minus 3s square plus 6x minus 100. Differentiating both the sides with respect to x, which implies this f dash x is equal to 3s square minus 6x plus 6. Clear? Which is same as 3s square minus 2x plus 1 plus 3. Clear? 3s square minus 6x plus 3 that is equal to 6, which is the same as x minus 1 whole square plus 3. Implies f dash x greater than or equal to 3. At x equal to 1, f dash x is equal to 3. Otherwise, its value greater than 3. So, f dash x greater than or equal to 3 for all x belongs to real set. Which implies f dash x greater than 0 for all x belongs to real set. Therefore, f is strictly increasing on R. Clear? Note down. Note down. Clear? Okay. Next question. Find the intervals in which fx is equal to ln x divided by x greater than 0 is strictly increasing or decreasing. Find the intervals in which fx equal to ln x divided by x greater than 0 is strictly increasing or decreasing. Most important question. Clear? Find the interval in which fx equal to ln x by x greater than 0 is strictly increasing or decreasing. Answer, fx is equal to ln x divided by x greater than 0. Differentiating both the sides with respect to x. It is in the u by v form. F dash x into 1 by x minus ln x into derivative x is equal to 1 whole divided by s square. Clear? Which implies this f dash x is equal to 1 minus ln x divided by s square. f is strictly increasing if f dash x greater than 0, which implies this. F dash x is equal to 1 minus ln x divided by s square. 1 minus ln x divided by s square greater than 0, which implies this 1 minus ln x greater than 0. Since x greater than 0, s square greater than 0. Clear? Which implies this 1 greater than ln x. 1 can be written as ln e greater than ln x. Ln x is an increasing function. Y is equal to ln x. It is the graph of y is equal to ln x. Ln x is an increasing function. Ln x is an increasing function, which implies this e greater than x. Since ln x is an increasing function, fx2 greater than fx1 or x2 greater than x1. Ln e greater than ln x, which implies this e greater than x. Since ln x is an increasing function, which implies this x less than e, which implies x belongs to open bracket 0 to e. Therefore, f is strictly increasing on 0 to clear. F is strictly decreasing implies this f dash x less than 0. What is f dash x? 1 minus ln x divided by s square. 1 minus ln x divided by s square less than 0. Which implies this 1 minus ln x less than 0. Since x greater than 0, s square greater than 0. Which implies this ln e less than ln x. Ln e is equal to 1. Ln e is equal to 1, which implies this e less than x. Since ln x is an increasing function, f is increasing fx2 greater than fx1 for x2 greater than x1, which implies this x greater than e, which implies this x belongs to open bracket e to infinity. Therefore, f is steadily decreasing on open bracket e to infinity. Clear? Clear? No. Next question. Find the intervals in which fx equal to sin 3x minus cos 3x, x greater than 0 less than pi is steadily increasing or steadily decreasing. Answer: fx is equal to sin 3x minus cos 3x, x greater than 0 less than pi. Differentiating both the sides with respect to x, f dash x is equal to 3 cos 3x plus 3 sin 3x. Clear? The point at which the derivative is 0, at its neighboring interval, the derivative is either greater than 0 or less than 0. So put f dash x is equal to 0, which implies 3 cos 3x plus 3 sin 3x is equal to 0, which implies sin 3x is equal to minus cos 3x, which implies tan 3x is equal to minus 1. Sin by cos, which is equal to tan minus pi by 4. Tan minus theta is equal to minus tan theta. Tan 45 is equal to 1. So it is minus 1. Tan x is equal to tan alpha. X is equal to n pi plus alpha. X means 3x. N pi plus alpha. Alpha means pi by 4. Minus pi by 4. N belongs to z set. Since tan x is equal to tan alpha, implies x equal to n pi plus alpha. N belongs to z set. Z set means set of integers, which implies x is equal to 1 by 3 n pi minus pi by 4. Here n belongs to z set, that means set of integers. For n is equal to 0, n is equal to 0 implies x is equal to minus pi by 12, not belongs to 0 to pi. We have to test the increasing and decreasing in the interval 0 to pi. Minus pi by 2 does not belongs to 0 to pi. For n is equal to 1, x is equal to 1 by 3 pi minus pi by 4, that is equal to 1 by 3 pi by 4 is equal to pi by 4, which belongs to 0 to pi. Open bracket. Clear? For n is equal to 1, 2, x is equal to 1 by 3 into 2 pi minus pi by 2, that is equal to 7 pi by 4. 7 pi by 12 belongs to 0 to pi. It is also true. For n is equal to 3, implies this x is equal to 1 by 3 4 pi minus 12 pi minus pi, that is equal to 11 pi. 11 pi by 4. 12 pi minus pi, that is 11 pi by 4, which is equal to 11 pi by 12. Belongs to 0 to pi. It is also true. For n is equal to 4 implies this x is equal to 1 by 3 into n is equal to 4, 16 pi minus pi, that is equal to 15 pi divided by 4, which is equal to 5 pi divided by 4, which is equal to pi plus pi by 4, does not belongs to 0 to pi. Clear? At x equal to pi by 4 and x is equal to 7 pi by 4, 12, and x is equal to 11 pi by 12, at which the derivative is equal to 0. The points at which the derivative is equal to 0, at its neighbor interval, the derivative is greater than 0 or less than 0. First point, for n is equal to, it is pi by 4. N is equal to, it is 7 pi by 4 by 12. N is equal to 3, it is 11 pi by 12, and it is pi, and it is 0. Clear? At x equal to pi by 4 or 7 pi by 12 or 11 pi by 12, the derivative is equal to 0. In this interval, the derivative may be less than 0 or greater than 0. Similarly, in this interval, and in this interval. For x greater than 0, less than pi by 4. For x, f dash x is dash. If x greater than 0, less than pi by 4, f dash x is dash. Less than 45 degree, it is positive. It is also positive. So the derivative implies this f dash x greater than 0. For x greater than pi by 4, less than, in this interval, f dash x greater than 0. 7 pi by 12 implies this f dash x less than 0. For if it is positive, then it will be negative. If it will be negative, then it is positive, and so on. X greater than 7 pi by 12 less than 11 pi by 12, f dash x greater than 0. For x greater than 11 pi by 12 less than pi, f dash x in this interval, f dash x less than 0. In this interval, f dash x greater than 0. In this interval, f dash x less than 0. Clear? In this interval, the derivative is greater than 0. In this interval, the derivative less than 0. In this interval, derivative greater than 0. In this interval, the derivative less than 0. Clear? Implies this f dash x less than 0. So the function is increasing in this interval and in this interval, and decreasing in this interval and in this interval. Since the derivative greater than 0, the interval in which the derivative greater than 0 is called increasing interval. The interval in which the derivative less than 0 is called decreasing interval. Therefore, f is strictly increasing on open bracket 0 to pi by 4 union 7 pi by 12 to 11 pi by 12 open bracket, and f is steadily decreasing on pi by 4 open bracket pi by 4 to 7 pi by 12 union 11 pi by 12 to open bracket pi. In this interval, the function is increasing. On this interval, the function is decreasing. Clear? Clear? Next question. Prove that the function f defined by fx is equal to s square minus x plus 1 is neither increasing nor decreasing in open bracket minus 1 to plus 1. Hence, find the intervals in which first bit the function is steadily increasing, second bit the function is steadily decreasing. Answer: the function is defined by fx is equal to s square minus x plus 1 on open bracket minus 1 to plus 1, which is same as s square minus 2 into x into half plus half square plus 1 minus 1 by 4. Clear? 1 by 4 cancel. 2 cancel, which is same as s square minus x plus 1. X minus half square plus this value is 3 by 4. Clear? Differentiating both the sides with respect to x, which implies f dash x is equal to 2 into x minus half. Clear? Or strictly increasing f dash x greater than 0, which implies x minus half greater than 0, which implies x greater than half. Clear? Therefore, f is strictly increasing on open bracket half to up to 1. Clear? Since the function is defined on -1, open bracket -1 to 1. For steadily decreasing, f dash x less than 0, which implies this 2 into x minus a half less than 0, which implies this x minus a half less than 0, implies this x less than half. Therefore, f is steadily decreasing on -1 to half, open bracket. Clear? As the function is increasing on up to 1 and decreasing on -1 to half, open bracket, implies this the function is neither increasing nor decreasing on, open bracket, -1 to +1. So the first part is proved, hence proved. Prove that the function f defined by this is neither increasing nor decreasing in, open bracket, -1 to +1. Hence, find the interval in which f is steadily increasing. First part, fx is steadily increasing on up to 1. Second bit, fx is steadily decreasing on -1 to half. Clear? Clear? Okay. Next question. So that x minus sin x is decreasing nowhere. So that x minus sin x is decreasing nowhere. Answer, let fx is equal to x minus sin x. Differentiating both the sides with respect to x, which implies f dash x is equal to 1 minus cos x. For decreasing f dash x less than 0, which implies 1 minus cos x less than 0, which implies cos x greater than 0, which is impossible. Clear? As cos x greater than equal to minus 1 less than equal to 1 for all x belongs to R. Therefore, f is decreasing nowhere. Hence proved. Clear?